In this session, we will examine the video frame log files kept by the Karrera and Kayenne software. The logs covered here are version 4.0. Logs in older versions of software will look slightly different. These logs are transferred when the diagnostic data is saved from the engineering status menu. The active log files can be examined by connecting to the frame IP address using a web browser and selecting Frame Message Logs from the sidebar. The logs are stored in a 40-page revolving log file so that available memory is not used up. Once the log gets to a specific size, it rolls over to a new page and erases the oldest page once 40 pages have accumulated. Selecting Current will show the active log page, which can be blank. Selecting Next from the current page will show the oldest page in the log. Whenever a reboot or a power cycle is performed, a new page is started and various boot information is inserted into the log file. To find the most recent boot, simply keep pressing Previous from the current page to find the last boot up sequence if it still exists in the log. In this example, a boot sequence appears on the current page. The boot up inserts the frame identification information at the top of the new log page, which makes it easy to find. The log sequence is typically the same each time, but some lines may not always be in the same order. Let's examine some of the information shown in this log file. The frame identification shows the type of frame that we are connected to and the current software version. This area shows the initial loading of FPGAs on the main processor board. FPGAs are hardware components that need to be programmed when the switcher is turned on. On the processor board, these include the sync generator, half-ME, and image store FPGAs. Scrolling down, we next see the ME boards detected and their FPGA configuration starting. All of the FPGAs on the ME boards are configured, initialized, and then started together. The mix effects boards are labeled based on their frame location. ME board A is located in the top slot in the frame, and the EDPM or option board O is located at the bottom of the frame. Scrolling down, we next see the system date and time information. This is followed by the system ID number and the number of allowed mix effects for this system. The license authorization codes are also displayed along with various options that the code enables. Various tasks are also being started to perform functions required for system operation. There will always be tasks relating to 2 suites, even if only one suite is being used. Scrolling down, we next see an important task starting relating to real-time field rate operations. This is followed by the reloading of last used system configuration file or engineering setup file. This system also shows that setdef and matchdef licenses are not available. Next, we see threads relating to any remote aux panels and external router connections starting up. Moving down further, we see connections to external devices being initialized, in this case, the clip store. Among the messages, we also see the panel preferences load starting and ending. Again, there will be one of these for each suite. Next, we get confirmation that the field rate task has begun and that this frame is switchable. Switchable means that the frame can now switch video and the FPGAs are loaded. We next see a control panel trying to connect and succeeding. Some messages are displayed twice for diagnostic purposes. Next, there is a confirmation of all of the mix effect board's configuration being completed and some menus connecting into the frame. There may also be some DID information lines present in the log file. The gigabit Ethernet MAC address of the frame network interface card is also included in the log. Here a router connection has been established. Any menus connecting will automatically be logged into their assigned suite. Scrolling down again shows the suite profiles loading and the current system standard information being displayed. Suite 1 loads before Suite 2. This is followed by any existing EMEM registers being reloaded. This in turn is followed by EDPM registers and any RMEM registers that may exist. Following the loading of all of the effects memory registers, the non-volatile saves enabled message appears. This indicates that the switcher has booted and memory has been reloaded. The switcher is now fully operational. Do not change sync standards in the frame prior to this time. From this point onwards, messages relate to non-boot operations such as menus, panels, or machines that may be disconnected or reconnected into the system. A warning message, indicated by a W on the left side of the log, is displayed when any device that has connected becomes disconnected. When examining log files, any message that indicates that a process failed or did not complete is cause for investigation. Warning messages can be normal. For example, if a machine is offline but is listed in the switcher configuration file, an error message will be seen in the log. Date and time information refers to the switcher frame settings. This completes the session on examining Kayenne Karrera log files.